Hello, we are going to be looking at dilations and finding the scale factor from a pre-image to its image. So this is really important over here. It states the scale factor of a dilation is the ratio of lengths in the image after the dilation to the corresponding lengths in the original figure. It tells you how much the dilation enlarges or reduces the figure. So when we look at this, we're talking about a ratio of finding the lengths from the image to the pre-image. So we kind of set this up as a ratio or as a fraction. So we start with the new length, so the length of the side from the image, and we have this over the pre-image or the original. And I'll change this to, instead of saying new, we'll say that this is our image and that is over our pre-image. And as we set this up as a ratio or a fraction, that's where we simplify, and that will give us the ratio or the scale factor from either enlarging the shape or reducing it. And that's another thing, specifically with dilations. I know we've been talking about transformations, we talked about translations and rotations and reflections, and none of those transformations would change the size or the shape of the pre-image to the image. When we talk about dilations, it is going to change the size. It's not necessarily going to change the shape, but it is going to make it larger or smaller. So it's not going to be the exact same units or the same length size that we had with the pre-image. So let's look at some examples of finding the scale factor. So let me clear this and we're going to look at some examples. So this first one says the parallelogram DEFG is a dilation of the parallelogram DEFG. What is the scale factor of the dilation? So we have to make sure that we're very clear with this too, that DEFG is our pre-image. This is what we're starting with, okay? This is the original, this is what the original shape that we had. Now we have this here, DEFG. This is our image. So this is the result of completing the dilation from the scale factor that we had, which is what we're trying to find. So this is going to change the shape. And this is where we also need to set up, how do we find this ratio? Okay, so we've got our pre-image over our image. Okay, the first thing we're going to look at is we want to use corresponding sides. And so with this side DE, this would probably be the best to start with. And this is 2 units because it's not a slanted line. It's clearly on the y-axis. It shows you that it is clear to 2 units. So we would write this as 2 in our numerator. And then we want to use the corresponding side, which is DE here. This would be 1, 2, 3, 4, 5, 6. And so that would be the length on the pre-image side. Now you could also use the side GF here or GF here, but remember they have to be corresponding sides. So that's where we would have to use this one and this one, or we could use the other one, but we can't use DE and then GF of the image. Okay, so it does have to be the corresponding sides. Once we complete that dilation, this side DE results in this smaller side. And that's another thing we also want to look at. If we can clearly see that DEFG is much larger than the image of DEFG, we know that we are reducing our pre-image. We are completing a reduction, or we're making it smaller. Okay, which usually means that our scale factor should be a fraction. Okay, it's always going to be a fraction of a whole. And so we're on the right track after setting up this ratio. The next thing that we need to make sure that we complete is we have to simplify this once we have found the ratio. So simplifying fractions, we want to think about what number will go into both the numerator and the denominator. And I want to start with 2 because that's in the numerator. I know the denominator is also divisible by 2. So I'm going to divide both by 2. 2 goes into 2 one time, and then 2 goes into 6 3 times. So this is going to tell me that my scale factor to get from this pre-image to this image is going to be 1/3. This is also going to tell me that I am reducing my pre-image. Okay. All right, so we're going to keep going with this. I'm going to clear this out, and we are going to move to another example here. Now we have the trapezoid TUVW is dilation of the trapezoid TUVW. What is the scale factor? Okay, so we know that TUVW is our pre-image. And when we look at the graph, we can see that that is the smaller green trapezoid, okay? And then we have TUVW. This is our image, and it's much larger, which means that we are enlarging the pre-image by multiplying it. This is going to result in a whole number as our scale factor, okay? So we want to look at our sides and we want to pick corresponding sides. And so I'm going to, and you can use, as long as it's not a slanted line. So like if we picked this line, this would be where we would be looking to find the slope of that line. So we're not going to do that. We're going to focus on this side here. So we'll focus on this side here, which is also corresponding to this side over here. Now, remember, we want to have the image in the numerator and the pre-image in the denominator. And this is how we're going to set up our ratio. So the image would be this one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units long. And then the pre-image would be 2 units long. And since we know that this is going to be a whole number and this kind of matches up 10 over 2, we got to think about this as division. Okay, so 10 divided by 2, that is going to give me a scale factor of 5, which means that each one of these corresponding sides is multiplied from the pre-image to get to the image. So this side is multiplied by 5 to get to this side over here. You have to enlarge all of the sides, which results in our image that we see with this blue trapezoid. All right, let's look at another example. We're still looking for that scale factor, solving for the scale factor of certain, from pre-images to the image. So this is a parallelogram, and it is dilated. We want to figure out what the scale factor is. So we've got W, X, Y, and Z, which is our pre-image. And then we have, let's do this different color, W, X, Y, and Z, which is our image. And when we look at this, I want you to just take a minute and look to see, when we go from the pre-image to the image, are we making the pre-image bigger or are we making it smaller? Okay, and that's going to tell you a lot of whether or not you're dealing with a scale factor of a whole number or a scale factor of a fraction. So when we look at this, we can see that the larger purple parallelogram is our pre-image, and then the smaller purple parallelogram is our image. So we are actually going to be reducing the pre-image to get to the image, which means that we're dealing with a fraction. So we're going to start with our image. We're going to set up our ratio here, our image over our pre-image, and then we're going to plug in our numbers. So I'm just going to look at this side here since I already have it marked. So this is 1, 2, 3. Now I just counted this side. This is 3 for the pre-image though. Okay, so I want to make sure I put this on the denominator on the bottom. Okay, and then our image is here. Corresponding sides is going to tell us it's YZ, and that is only 2. And so this is going to tell us that our scale factor here is 2/3. And this is a really great way to check your answer too, because we determined that we were reducing the pre-image down in size to get to the image. And so if I got a whole number with this, I would know that something was, maybe I had flipped my fraction upside down, I wrote it incorrectly. But when you're reducing it, you should be getting a fraction for your scale factor value, okay? As long as you're picking out corresponding sides, and as long as they're like straight lines like this, so X, W, X and W, these, you could also use these as well. You would get the same answer. When you pick this side, if you pick this side, this is a slanted side. That's where we would need to find the slope of that line, okay? So it would take a little bit more than just counting the units. Let's look at another example here. We have the parallelogram HIJK. We have to determine the scale factor. So HIJK is our pre-image. This is what we're starting with. And HIJK is our image. This is what we're going to result with. So we want to determine, the first thing we're going to do, what we kind of did with the last example, we want to kind of look at this and determine, am I making this larger or smaller? As I go from the pre-image to the image, am I making this shape bigger or am I reducing it in size? And in this case, the parallelogram that's in orange, that is our pre-image. And then the parallelogram that's in purple, that is going to be our image. So our pre-image, we are enlarging it. We are going to enlarge the pre-image to get to the image, which means that we should be getting a whole number as our scale factor. So we're going to set up our ratio. Remember, the image is in the numerator, the number for the image is in the numerator, the number for the pre-image is in the denominator. So I'm going to pick a side. I'm just going to go with this side here, JI. This is part of my pre-image that I just highlighted. So 1, 2, 3, 4, 5, 6, 7, 8. And this number would be what we would use for the denominator. And then we have to use the corresponding side. So we're going to use this one up here, which is part of our image. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units for our image. And now we can simplify this. We know 16 over 8 fractions are division. So 16 divided by 8 would give us a scale factor of 2. To get from our pre-image to our image, we would multiply all of those sides by 2 to get to the image, to get to the new figure that we have. And again, it's important to point out too that with dilations, we're not really changing the shape of the object. We're just changing the size. We're reducing it or we're enlarging it according to what the scale factor is letting us know. Okay, there will be, if it is a correct dilation, there will be a scale factor that will be associated to all of the sides. So as long as the scale factor is the same, we can say that it is, we are dilating that shape. All right, so we're going to look at another example here. Now we have a triangle here. So triangle STU, and we want to figure out what the scale factor is. So STU is our pre-image. And then we have STU as our image. So looking at these triangles, we know that the larger purple triangle is our pre-image, okay? And how do we know that? Because we have this S here, it does not have the apostrophe next to it, so that's going to tell us that it is the original coordinate, okay? So now that I have this, I can see that I am taking this purple triangle and I am reducing it in size to get to the blue triangle. So this is an example of reducing the triangle. So we should get a scale factor that is a fraction, okay? Now I have my image in the numerator and I have my pre-image in the denominator, and I am going to look at the sides. Now with this one, it's kind of like this side would not be a good side to use because again, we'd be finding slope. Even this side would not be good because it's not on those units. It's kind of a slanted line. We would have to find the slope of that line. So in this case, there's really only the one good side that we can use to find the scale factor, and that would be ST over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be our image. And then we're going to use the same corresponding side over here. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. 9 over 18. We want to make sure, though, that we simplify, because with this as a scale factor, as a fraction, we want to make sure we write it in simplest form. And so we want to think about what number can go into both 9 and 18. I know we can probably say 3, but there is a number that is higher. We can actually divide 9 into both 9 and 18. And that would give us 9 goes into 9 one time, and then 9 goes into 18 two times. And so this would tell us that our scale factor for this is going to be 1/2. Now, I know that we've talked about checking your answer, but if I got, let's say I got the scale factor of 2 as my answer, but I know that this is a reduction, that we are reducing the pre-image to get to the image. What I would want to do is then take a look back on how I set up my ratio. Did I write this as my image over my pre-image, or did I flip it the other way? Because that will influence your answer. And so if you know that you're reducing the pre-image, you want to make sure that your answer is a fraction, okay? And then one more example that we have here. So we have this triangles again. We're dealing with U, V, W. This is our pre-image. And then we also have triangle U, V, W as the image. Okay. Now, this one looks a little bit different because all of the other examples we looked at, it seemed like the shape was still inside. If we were reducing it, it was still inside of the pre-image, okay? We can still have this just depending on what the scale factor is that we find. So what we want to do first is we want to decide, am I enlarging it or am I reducing this pre-image to get to the image? And in this case, my U here is my part of my pre-image, and I have to take it to this one here, and this triangle is much smaller than the green triangle. So that would mean that, again, I am reducing this pre-image to get to the image, which also means will let me know that I am going to be dealing with a fraction for this one. Okay, so my ratio is set up as my image over my pre-image, and I encourage you to write this down, maybe with all of the questions as practice, because this will kind of help you to remember this is how we set up the ratio, okay? Again, with this triangle, it's going to be kind of hard to use this side or this side because this is where we would need to find the slope of those lines. And so what we're going to do instead is we're going to use this line down here, and we're going to use VW down here. So part of the image we have, this is just 1 unit for VW. And then for the pre-image, we have 1, 2, 3, 4, and 5 for the pre-image. And that's going to tell me that my scale factor for this one is going to be 1/5. And I can confirm that I was on the right track, that this has got to be the scale factor because I know that I am reducing the pre-image to get to the image. And so that is going to be where I do get a fraction for my scale factor. This is very important. I would make sure that you have this ratio written down so that you can use this as you're setting up your own questions.